Hello, everybody. My name is Amar Ayar. I'm an application engineer at Maxim Integrated. In today's video episode, we'll talk about the MAX16136, a supervisory IC with overvoltage fault detection capability, and how that is important in maintaining system safety in an automotive environment. And I'm going to use this board to demonstrate that capability. A few words about the automotive system. If you look into these systems, you'll find a lot of diagnostics and safety measures and whatnot to ensure fault conditions are detected. Now, one area where this actually becomes important and critical is in monitoring the supply rail of the system for disturbances. Traditionally, these rails have been monitored for undervoltage fault, but because of the safety concerns in automotive environment, it's also important to monitor these rails for overvoltage fault condition as well. Now, why that is important? Well, it's important because in these systems, you'll find components such as microcontrollers, SOCs, and other circuitries that operate within very precise voltage level or voltage range. And if there's an overvoltage fault condition gone undetected in these systems, can actually damage these components and degrade the system safety mechanism or integrity. To maintain that safety level and also optimize that safety level in a system, Maxim offers the MAX16136, which is a supervisory IC with overvoltage fault detection capability. What is unique about the MAX16136 is that in addition to resetting the system in an event of overvoltage fault condition, it also offers or features an overvoltage fault output, which is a latch output, and we'll see how that is important in a bit during this demonstration. As far as this board is concerned, we will be focusing on this area of the board right over here, where you have the MAX16136 located here, interacting with the LDO right above it. On this board, the output of the LDO, which supposedly provides the system rail, is directly connected to the monitoring input of the MAX16136. Two things will happen when I power up this board and create an overvoltage fault condition. First, the reset output will assert, and that is indicated by this LED lighting up. Simultaneously, the overvoltage fault output will also assert, and that is indicated by this LED right above it, and it's going to light up when there's an overvoltage fault condition. At the same time, we have this display unit that will tell us what is the voltage of the LDO for normal operation, and then when there's a fault condition. So I'm going to power up the board using this compact power supply unit, and I'm going to use this cable right over here that's going to connect my power source to the board. As you can see right now, the board is in normal operation, and the output of the LDO is about 3.26 volt, and there's no fault condition because the two LEDs are not lit up. Now I'm going to create the fault condition while keeping an eye on the output of the LDO, and also keeping an eye on the two LEDs that we mentioned before. So to create that fault, I'm going to use this potentiometer right over here, located to the right side of the board, and I'm going to turn it while keeping an eye on the LDO output on that display unit. And as you can see, it's increasing a little bit. Yeah, right there. So right now we have an overvoltage fault condition because the two LEDs are lit up. Meanwhile, you notice that the output of the LDO is not 3.3 volt anymore, it's sitting at 0. And that is because the overvoltage fault output of the MAX16136 is directly connected to the enabling input of the LDO. And that is very critical because in a real system, if you have an overvoltage fault condition on a system rail for a prolonged period of time, it can actually damage sensitive components in your system. So the better approach is to make sure that it is disabled. And that's exactly what the MAX16136 is doing on this board, disabling that system rail to save the system or critical components on the system. Now, there's two things we can do to bring this board out of this condition. First, we need to eliminate or remove that fault condition that we created, and that is done by bringing that potentiometer back to the original position. And then we also have to pull the clear input of the MAX16136 to ground momentarily, and I will do that by using this push button switch right over here. As you can see, the output of the LDO is back to 3.3 volt, which is the normal operating voltage supply for this board. And the board is back to normal operation. So as I demonstrated in this video, the critical functionality that the MAX16136 offers in order to keep your system safe, not only safe, and also enhances that safety level as well. For more information on this device, the MAX16136, visit our website at www.maximintegrated.com/max6136, and thanks for watching.